All you need to know is that today we are going to talk about whether quantum mechanics is indeed a complete nonsense. And if you stick around until the end of the video, we will find out whether the great Albert Einstein was right about his famous quote. But before we begin, quantum mechanics, quite possibly the most mind-bending field of study ever to be invented by humans. It was born in the early 20th century when scientists began to understand that Newtonian physics, which had been so successful during the previous centuries, was simply not enough to explain how things worked at the smallest scales. This led to the birth of a completely new set of physical laws, which we now call quantum mechanics. But these laws were anything but intuitive. In the quantum world, particles can exist in multiple states at once. They can tunnel through barriers, and they can be linked together in ways that allow them to instantaneously influence each other. And it turns out that these phenomena do not happen only at the smallest scales. They actually happen everywhere. And this includes you, me, and the very device you are watching this video on. But why did all these brilliant scientists who had dedicated their entire lives to the study of physics start calling quantum mechanics a complete nonsense? Well, there were many reasons for this. First of all, the theory contained elements that seemed to contradict our everyday experiences. How could something be in two places at once? And if it is, then how does it decide where to be when we look for it? Secondly, the theory was highly abstract and relied on concepts such as wave functions and operators, which were unfamiliar and difficult to understand. Moreover, quantum mechanics seemed to introduce an element of randomness into the laws of nature. This was particularly troubling to scientists like Einstein, who believed that the universe was deterministic and that all events were caused by previous events. And finally, quantum mechanics raised deep philosophical questions about the nature of reality, knowledge, and the role of the observer. These are some of the main reasons why so many people, including some of the brightest minds of the past century, started to call quantum mechanics a complete nonsense. And while there is no denying that quantum mechanics is a challenging subject that requires a lot of effort to understand, I think it is important to remember that it has also been one of the most successful theories ever developed by humans. It has accurately predicted a wide range of phenomena that have been tested and verified by experiments. Quantum mechanics has also led to many technological advances, such as lasers, transistors, and nuclear energy. And today, it is the foundation of many emerging technologies, such as quantum computing, quantum cryptography, and quantum teleportation. So the question is, should we throw away this incredibly successful theory just because it goes against our intuition, or because we find it philosophically unappealing? I personally believe that we should not. Instead, we should embrace the mystery of quantum mechanics and continue to explore its implications for our understanding of the universe. After all, just because we don't understand something doesn't mean it's wrong. And just because something is difficult to understand doesn't mean it's not true. Okay, so we have established that quantum mechanics is not a complete nonsense in terms of being an effective tool to describe the physical reality around us. But this does not necessarily mean that it is correct. You see, in the history of science, there have been many instances when a scientific theory was widely accepted by the majority of scientists, only to be later replaced by a more accurate and complete theory. Think about geocentrism, the idea that the Earth is the center of the universe. This theory was widely accepted for centuries, despite there being no evidence to support it. It was only when a more accurate and complete theory, heliocentrism, was proposed that we learned the truth about our place in the universe. This is why it is always important to keep an open mind and to be willing to challenge our own beliefs. One of the most famous critics of quantum mechanics was Albert Einstein. He was troubled by the probabilistic nature of the theory and the fact that it seemed to suggest that reality was fundamentally uncertain. Einstein famously said, "God does not play dice with the universe," referring to the role of randomness in quantum mechanics. However, despite his criticisms, Einstein's work was also essential to the development of quantum mechanics. His theories of special and general relativity provided the foundation for much of what we know about the universe today. And it was Einstein who first proposed the idea of wave-particle duality, which is a key concept in quantum mechanics. Another scientist who was critical of quantum mechanics was Louis de Broglie. He was concerned about the collapse of the wave function, which is a central part of quantum mechanics and essentially describes how a quantum system evolves over time. De Broglie argued that the collapse of the wave function was an unnecessary and mysterious part of the theory that should be eliminated. Despite these criticisms, de Broglie's work on wave mechanics was instrumental in the development of quantum mechanics. His thesis on the wave nature of electrons, which was submitted in 1924, is considered to be the starting point of quantum mechanics. There were many others, like Erwin Schrödinger, Werner Heisenberg, and many more who helped build this theory, and they all struggled with it in different ways. You see, quantum mechanics is a deeply counterintuitive theory that challenges our everyday experiences and our understanding of the world. It introduces concepts such as wave-particle duality, entanglement, and superpositions, which are difficult to understand and even more difficult to accept. The theory also suggests that the act of observation can influence the behavior of quantum systems, which seems to imply that reality is somehow created by the observer. Despite these challenges, quantum mechanics has been remarkably successful in explaining a wide range of phenomena in the natural world. It has been confirmed by countless experiments and has led to major technological advances such as lasers, transistors, and nuclear energy. The theory has also inspired a great deal of philosophical debate and has raised fundamental questions about the nature of reality, knowledge, and the role of the observer. In conclusion, while quantum mechanics has been highly successful in explaining the behavior of matter and energy at the atomic and subatomic level, it is still a work in progress. There are many aspects of the theory that remain mysterious, and there are many questions that scientists are still struggling to answer. The probabilistic nature of the theory, the collapse of the wave function, and the role of the observer are just a few of the areas that continue to be debated and explored by physicists. Some scientists even argue that quantum mechanics is not a complete theory and that there are deeper underlying principles that we have yet to discover. Ultimately, the success of quantum mechanics in explaining the behavior of the natural world is a testament to the power of human curiosity and the relentless pursuit of knowledge. Even though the theory is often difficult to understand and counterintuitive, it has revealed a universe that is far stranger and more wonderful than we could have ever imagined. And as we continue to explore the mysteries of quantum mechanics, we can be sure that we will uncover even more amazing discoveries that will change our understanding of the world forever. So was Einstein right when he said that quantum mechanics is a complete nonsense? Well, I would say that he was partially right. Quantum mechanics does indeed defy our intuition and common sense. It does introduce a level of randomness and uncertainty into the laws of nature that can be difficult to comprehend. And it does raise deep philosophical questions about the nature of reality and the role of the observer. However, I would argue that Einstein was wrong when he said that quantum mechanics is a complete nonsense. Because despite its strangeness and counterintuitiveness, quantum mechanics is a highly successful scientific theory that has accurately predicted and explained a wide range of natural phenomena. It is a theory that has led to countless technological advances and has deepened our understanding of the universe in ways that we could never have imagined. Yes, quantum mechanics may not make sense to us, but that doesn't mean it's not true. As scientists, we should always be willing to challenge our own beliefs and to embrace the mystery of the unknown. Who knows? Maybe one day we will find a way to make sense of quantum mechanics. But until then, we can marvel at the beauty and wonder of a universe that is stranger than we could have ever dreamed. If you liked this video, please leave a like and subscribe for more videos like this. Thanks for watching.